Hello everyone. Today in this episode we are going to discuss nature of a roots of a quadratic equation. Now I just recap the things we learned in the last episode. We learned how to find out the solution of a quadratic equation using the formula. If an equation is given to you by ax square plus bx plus c is equal to 0, then the roots of the equation is given by x is equal to minus b plus minus b square minus 4ac by 2a. Then x is equal to minus b plus minus b square minus 4ac by 2a. So we will obtain two values of x by one time we will take minus b plus b square minus 4ac by 2a, and another time minus b square minus 4ac by 2a. Now the roots of the quadratic equation is depend upon the factor b square minus 4ac. This b square minus 4ac we call it as a discriminant, b square minus 4ac. This is called as a discriminant of the equation. So d is equal to b square. Now what are the possible values of d? So there are only three possibilities. D might be greater than 0, or d may take the value 0, or d might take the value less than 0. So there are only three possibilities. B square minus 4ac might be greater than 0, or equal to 0, or less than 0. Now if d is greater than 0, suppose if I take one example, x square minus 5x plus c is equal to 0. X square minus 5x plus 6 is equal to 0. So if you compare this equation with ax square plus bx plus c is equal to 0, so you get a is equal to 1, b is equal to minus 5 and c is equal to 6. Now calculate b square minus 4ac. So d is equal to b square. B square means minus 5 square minus 4 into a into 6. So if you calculate, minus 5 square means 25 minus 24 is equal to 0. That is greater than 0 case. Greater than 0 case. Now if you find out the roots of this equation either by the factorization method, which already we have discussed in our first part, or by applying the formula which we have discussed in the second part of this. You can find those two parts in the description box. Now if you find, you will get the value of x as 2 or 3. If you find out the roots by factorization method or by applying the formula, you will get the two values of x as 2 or 3. Now from this discussion, what you conclude that 2 and 3 are real number. So if d is greater than 0, then roots are real. Roots are real and they are different. So you can say roots are real and distinct. So first case we have discussed, if d is greater than 0, then roots are real and distinct. Now if d is equal to 0, for example, if I take one example like x square minus 4x plus 4 is equal to 0. x square minus 4x plus 4 is equal to 0. Now same way if we compare with this equation, so you get a is equal to 1, b is equal to minus 4, c is equal to 4. Now calculate b square minus 4ac. So b square minus 4ac, that is minus 4 square minus 4 into 1 into 4. B square minus 4 into A into C. So minus 4 square is equal to 16, minus 16 is equal to 0. So now in this case we are getting the value of D as 0. Now if you solve this equation, x square minus 4x plus 4 is equal to 0 by any of the method, factorization method or solution, by applying the formula, you will get the value of x as 2, 2. Clear? Now see, both are equal and real. So in this case we conclude that roots are real and equal. Now check whatever we discussed with this formula. Now if this term b square minus 4ac becomes 0, so if you substitute there 0, then minus b minus 0, that is minus b by 2a, and if you substitute here b square minus 4ac as 0, then you will get minus b plus 0, that is minus b by 2a. So minus b by 2a minus b by 2a are the two roots. Am I clear to everyone? And if you substitute this one, so plus of something and minus of something will give two different. So if d is greater than 0, then roots are real and distinct. If d is equal to 0, then roots are real and equal. Now if you combine these two conditions, so we may say that d is greater than or equal to 0. If you combine these two conditions, so collectively we can term it as d is either greater than or equal to 0. In this case we can say that roots are real. Roots are real. Clear? Now when d is less than 0, so let's take one example, x square plus x plus 1 is equal to 0. X square plus x plus 1 is equal to 0. Now compare this with this equation. So you get a is equal to 1, b is equal to 1, c is equal to 1. Therefore b square minus 4ac is equal to, b square means 1 square minus 4 into 1 into c. That is 1 minus 4, it is equal to minus 3. Now this minus 3, if you substitute here, can you find out the square root of a negative number? No. Till now whatever we have the knowledge, it is not possible for us to find out the root of a negative number, square root of a negative number. Then we say that no real root exists. No real root clear? So this entire process we called it as a finding the nature of a root without solving it. See, we are not solving the entire equation. We are not finding the value of x to tell about the nature of the root. Just we are finding the discriminant and then we conclude that whether the roots are real and distinct, real and equal, or no real root exists. Clear? So this is the basic concept of this chapter. Using this discriminant we find out the solution or we will discuss some more problem to clear your concept. Let us discuss some problem based on the nature of the roots. Discuss the nature of the roots. Discuss the nature of the roots. of the following quadratic equation. Now first discuss this one. 3x square minus 5x minus 2 is equal to 0. So step 1, first we compare the equation with the standard form, that is ax square plus bx plus c is equal to 0. That is first we compare the equation with ax square plus bx plus c is equal to 0. Now if you compare these two equations, you will get a is equal to 3, b is equal to minus 5 and c is equal to minus 2. Now nature of the roots, so we need to find out the discriminant, that is d is equal to b square minus 4ac. b square minus 4ac. Now substitute the value. b is equal to minus 5. So minus 5 square minus 4 into a into c. So minus 5 square means 25, minus minus plus, 4 3 ja 12 multiplied by 2, 24. So this is equal to 49. Now 49 is greater than 0. We categorize the value of d into 3 parts. Greater than 0, equal to 0, less than 0. So d is equal to 49. That means greater than 0. So greater than 0 means roots are real. Greater than 0 means, first conclusion is roots are real. Greater than 0 means real and distinct. That means you will get two different values of x and both values are real. Clear? The question might also be given like this: find the discriminant of the equation and hence state the nature of the root. So in both the cases your solution will be like this. You need to compare with the standard quadratic equation, then find out the d using the formula b square minus 4ac, and then calculate and find out whether the value of d is greater than 0, less than 0 or equal to 0. Same way, if you discuss this problem, 2x square minus 3x plus 5 is equal to 0. So here a is, if you compare these two equations, so a is equal to 2, b is equal to minus 3 and c is equal to 5. Next step is, we write down the formula of d. d is equal to b square minus 4ac. b square means minus 3 square minus 4 into a, 2 into c, that is 5. Minus 3 square means 9, minus 3 into minus 3, 9, minus 4 to ja 8, 8 5 ja 40. 9 minus 40, it is equal to minus 31. Minus 31, it is less than 0. Now if d is less than 0, that means it is a third case where no real root exists. No real root exists because you cannot find square root of minus 31. So here we say that no real root. Clear? Moving on to the next problem. 3x square minus 2x plus 1 by 3 is equal to 0. First, either there are two ways you can do it. First, simplify this one and write it in the standard form, or you can directly apply the formula b square minus 4ac. So for your convenience, first I am simplifying this equation. So LCM will be 3. LCM will be equal to 3. Then you will get 9x square minus 6x plus 1 is equal to 0. So if you cross multiply this, so 3 into 0, 0. So you will get 9x square minus 6x plus 1 is equal to 0. You can directly find out A is equal to 3, B is equal to minus 2 and C is equal to 1 by 3 and then directly apply the discriminant formula, or you may simplify it, write it in the standard form and then apply the formula. So now if you compare these two equations, so you get A is equal to 9, B is equal to minus 6 and C is equal to 1. Now we apply D is equal to B square minus 4AC. B square, that is minus 6 square minus 4 into A into C. B square minus 4AC. So this is equal to minus 6 square means 36 minus 36 is equal to 0. When D is equal to 0, roots are real and equal. So you write roots are real and equal. Roots are real and equal. Let us discuss this problem. 2 root 3 x square minus 5x plus root 3 is equal to 0. So if you compare with ax square plus bx plus c is equal to 0, you get a is equal to 2 root 3, b is equal to minus 5 and c is equal to root 3. Now apply the formula d is equal to b square minus 4ac. So b square, substitute the value of b as minus 5 square minus 4 into a into c. So minus 5 square is equal to minus 5 into minus 5, that is 25 minus 4 to the 8. Root 3 into root 3 is equal to 3. So 8 into 3 is equal to 24. 25 minus 24 is equal to 1. So 1 means we write d is greater than 0. 1 is greater than 0. So when d is greater than 0, therefore nature of the roots will be real and unequal or distinct. So it conclude that roots are real and or you may also write it as two different real roots. Two different real roots exist. Let us discuss another problem. Without solving the following quadratic equation, find the value of p for which the roots are equal. An equation is given to you. We need to find out the value of p such that the roots are equal. Now, if first we compare this equation with the standard form, that is ax square plus bx plus c is equal to 0. So we write comparing with ax square plus bx plus c is equal to 0. We get a is equal to p, b is equal to minus 4 and c is equal to 3. Clear? Now it is given that roots are equal. So we write, since roots are equal, so if the roots are equal, d will be equal to 0. So d will be equal to 0. So now d is equal to 0 means b square minus 4ac should be equal to 0. It implies b square minus 4ac is equal to 0. Now we substitute the value of a, b and c in this equation. So b means minus 4 square minus 4 into a into c is equal to 0. So minus 4 square means 16, minus 4 into minus 4 is equal to 16, minus 4 3s are 12, p is equal to 0. So if you take this 16 to other side, so minus 12p is equal to minus 16, minus and minus will get cancelled. So p is equal to 16 by 12. Cancel out the term. It will cancel with 4. 4 3 ja, 4 4 ja. So it implies p is equal to 4 by 3. That means if p is equal to 4 by 3, the given equation have equal roots. So again I repeat, the question is given and equation is given to you and condition is given that you have to find out the value of p such that the roots are equal. So we apply the condition. If the roots are equal, then b square minus 4ac is equal to 0. From that equation we find out the value of p by substituting a, b and c. Let us discuss this problem. It is the same as what we discussed in the last problem. This equation we have to find out the values of k for which the quadratic equation has the equal roots. Now see, this equation already arranged in standard form. X square, x and constant. So first we need to compare with ax square plus bx plus c is equal to 0 to find out the values of a, b and c. So here a is equal to 1 because x square is there. So x square can be written as 1 into x square. So if you compare with ax square, so a will be equal to 1. B is equal to minus 2 into 5 plus 2k and C is equal to 3 into 7 plus 10k. B is equal to, so by comparing with ax square plus bx plus c is equal to 0, we will get the value of a, b and c. Now next, the condition is given that the quadratic equation has equal root. Equal root means d is equal to 0. So we write, since the roots are equal, therefore d is equal to 0. It implies d is equal to 0 means b square minus 4ac is equal to 0. Now substitute the value of a, b and c in the given equation. So b is equal to minus 2 into 5 plus 2k square minus 4 into a is equal to 1 into c means 3 into 7 plus 10k is equal to 0. Now minus 2 into 5 plus 2k square. So minus 2 means, minus 2 square means 4 into 5 plus 2k square minus 4 into 3, 12, 7 plus 10k is equal to 0. Now to simplify our calculation, from these two we can take 4 as common, and once you divide it by 4, this 4 will eliminate. So first we are taking 4 as common. So this will be equal to 5 plus 2k square. 4 common. So 12 divided by 4 is equal to 3 into 7 plus 10k is equal to 0. Clear? So in next step, when you send this 4 to that side, it will be equal to 0. 0 divided by 4, 0. Now we expand this term in the form of a plus b square. So a square, that is 5 square, 25 plus 2 into a into b. 2 into a into b, that is 5 into 2, 10. 10 into 2, 20k plus 4k square. We are expanding this in the form of a plus b square. So a square plus 2ab plus b square minus 3 into 7, 21 minus plus minus 3 into 10, 30k is equal to 0. Now we arrange it in the standard form because we are getting the quadratic equation again. So first we write k square term, 4k square, 20k minus 30k. So that will be equal to minus 10k. 25 minus 21, that is equal to plus 4 is equal to 0. Either you can directly apply factorization method or formula to get the value of k. My suggestion is again you will take 2 common from this, that will reduce your calculation. So if you take 2 common, so you will get 2k square minus 5k plus 2 is equal to 0. So if you divide both sides by 2 or you take these 2 on the other side, 0 by 2 is equal to 0. So we are getting as 2k square minus 5k plus 2 is equal to 0. So 2k square minus 5k plus 2 is equal to 0. If I apply the factorization method, then 2k square product is 2 into 2, 4. So 5 can be written as 4 plus 1 into k plus 2 is equal to 0. 2k square minus 4k minus k plus 2 is equal to 0. We are multiplying 4 into k, outside sign is negative, so it will be minus 4k. And if you multiply 1 into k, outside sign is minus, so it will be minus k. From the first 2 terms, we can take 2k common, so that will be equal to k minus 2. And from here, we need to take minus 1 common. Then we get k minus 2 is equal to 0. So we get k minus 2 into 2k minus 1 is equal to 0. So we can conclude that product of 2 terms is equal to 0. So either of them must be equal to 0. So we say either k minus 2 is equal to 0. It implies k is equal to 2. Or 2k minus 1 is equal to 0. It implies k is equal to 1 by 2. So for k is equal to 2 or k is equal to 1 by 2, if you substitute in the given equation, you will get the roots of the equation has real equal roots. Moving into the next problem, find the value of p for which the equation px square plus 4x plus 1 has real root. Real root, there are 2 conditions for which the roots of the equation are real. If d is equal to 0, then roots are real and equal. If d is equal to 0, then the roots are real and equal. And if d is greater than 0, then the roots are real and distinct. Roots are real and different. You will get two different values of x, and those two values are real. So combining this equation, these two parts, we can say that if d is greater than equal to 0, then the roots are real. So we write the equation px square plus 4x plus 1 is equal to 0. So first we compare with ax square plus bx plus c is equal to 0. So we get a is equal to p, b is equal to 4 and c is equal to 1. So b square minus 4ac is equal to 0, greater than 0. So we write, since roots are real, it implies d should be greater than equal to 0. It implies b square minus 4ac greater than equal to 0. Now substitute the value of a, b, c. B square means 4 square minus 4 into a into c is greater than equal to 0. So 16 minus 4p greater than equal to 0. So if you take 16 on the other side, so minus 4p is greater than equal to minus 16. Now if you remember the inequation, if you cancel out this negative, then inequality sign will change, or you divide it by minus 4. So by multiplying with negative or dividing with negative term, inequality sign will change. So here we write p is less than equal to minus 16 by minus 4. Minus minus cancel, 4 4 ja. Therefore p is less than equal to 4. It means that for all those values of p less than equal to 4, if you substitute in this value, the given equation has real root. So here we will not get the particular value of x, but the set of numbers which satisfies the given condition. So I hope you understand the topic. If you find, now I request you to solve the exercise from your textbook, whatever the textbook you are following. Solve the exercise based on nature of the roots. If you find any difficulties while solving the problem, or you encounter with any other kind of problem given in your textbook, you may write those questions or question number in the comment box. I try to solve it and upload the video as soon as possible. Thank you very much.